Hi everyone, it's Miss Reister and welcome to your first flipped recording. This is going to be about a 10-minute recording of me going through 1.01 Introduction to Science. I'll hit some hot spots on things that you might want to write down or focus on and just talk you through working through this lesson. So you do want to be sure you have something to take notes with during this recording. This part isn't as relevant right now. You're just going to want to get things ready to take some notes, and we're going to be starting that discussion on your science notebook. So as we look at the course, this is the teacher view of the course, so it's going to look a little bit different than what you might see when you log in, but this is the science homepage. So from here we want to go to Content. And if you have not yet completed all the orientation, then you won't see any of this down here yet. So all the content in the course will be hidden until the orientation module is complete. Extra credit will be coming soon. So let's take a look at 1.01. And the first thing we come to is the course introduction. So this is the only time you will see a course introduction until you get to the B course. And a couple of things to jot down here. So we're looking at Introduction to Physical Science. Welcome to Physical Science, the study of matter and energy and how they interact. So physical science includes the study of physics and chemistry. So a couple of important things to know there. We're studying matter and energy, how they interact together. This includes physics and chemistry. So learning about physics and chemistry will give you a solid foundation for understanding how the physical world around you works. Begin your journey into physical science by learning about practices used by scientists and engineers. So I want to show you also this option. If you ever get to a lesson that doesn't have a recording done yet and you want the lesson read to you, you can click this mode. And you do have to turn it on every time, but it is there in case you need it. So if we go on to the next slide, this is the introduction to the science notebook. So you saw a little bit about it in the orientation module. So we'll talk about it quickly, how to go through it. So it's asking you to access this link, and that this activity is going to teach you how to take notes and how to use this template. So you can use this to create a digital notebook, or you can recreate this template in an actual physical notebook, meaning you handwrite it. So that's up to you. Whether you use the template or a different note-taking template, you're going to label the start of each set of notes with the course name, unit name, and lesson name. So I have this open. We're going to take a look at what that looks like. So when you get it, it will look like this. You're going to need to click. My mouse sometimes hides. Like it's there, but not. I'm not sure why it's not. There it is. Okay, so enable editing. Sorry, my mouse is not cooperating. It's lighting it up, but it's not visible. There we go. Sorry about that. So once you enable editing, now you are able to add some things to it. So this is where it is talking about clicking and changing this to physical science. We're in Unit 1, Intro to Science, and then the lesson that we're in right now is 1.01, Intro to Physical Science. So you'll want to update that each time. And then when you get to Lesson 2, 1.02, you'll just want to right-click and duplicate the slide. That way you have another one and it's ready to go. So with that in mind, let's go back here and see what it has us do. So keeping a notebook. Note-taking is an important skill. And when you read through a lesson or a book, watch instructional videos, and participate in classroom lessons, you're presented with large amounts of information. Note-taking helps you process all that information. Research has shown that note-taking helps you remember what you've learned. As you take notes, you form new pathways in the brain, which encodes the information in a new way that makes it easier to retrieve in your long-term memory. Organized notes also help you find the information later when you're studying for tests or quizzes. So studies do show that even handwriting things helps it transfer into your brain, into your memory. And so there are a couple different ways you can take notes. Again, we're in a digital age, so if you want to do your notes on the computer using this template, that is not a problem. But if you prefer to handwrite, that's your choice as well. So all methods provide a different way of organizing information. So it's just showing some popular outlining methods that you've probably used before. You've got an outline where you're using bullet points. You've got the Cornell method, mapping if you're a little bit more visual, and then boxing method also if you're a visual person, that may be helpful. And it talks about science and engineers keep detailed notebooks. Their notes often include labeled diagrams that help describe a scientific process or engineering design. Scientists do not delete or erase information from their notebook or tear pages from it, even if they make a mistake. They draw a line through mistakes so that you can still read the original writing. Everything is dated and written in a way that others can understand the information. So take a look at some famous historical notebooks and notice that they all include labeled diagrams. All right, so you're able to go through and notice that even some of the older notebooks that are historical have included labeled diagrams. So that's very helpful in science. So let's go back to the template you were giving. In this course, we are providing a science notebook template that combines several note-taking strategies. So you may decide to modify the template to better suit your learning style, and that is okay. The science notebook template is divided into two parts, input and output. On the right side, you'll record your notes from the course, lessons, and research. Each lesson introduction includes a set of guiding questions to help you identify the most important information in each lesson. So on the right side, you're going to want to make a note that every lesson has guiding questions. And we'll see an example of that coming up because there are guiding questions in this lesson. So when I grade this is, remember, part of your Part 2 test. It actually is your entire Part 2 test. I will be looking for those guiding questions in every lesson. So they'll need to be clearly identified and labeled. And then on the left side, this is where you're entering your notes. So diagrams, concept maps, some of those models that we saw up earlier with the boxing method, the mapping method, that is where you kind of have a little more freedom to jot down things in a way that's helpful to you. So this goes into a little more detail. There are more pages that goes into a little more detail on that input output. So we'll start looking into Intro to Physical Science and kind of go through, pick out the important things. These are things you would now start filling in on the left side of that template. So if we go back to that PowerPoint, that's right here. If you want to draw it, great. If you want to type it, bullet point, great. Either one is fine. And then over here, we'll get to those guiding questions in just a minute. So we're talking about essential question, how do scientists study the physical world? So write this essential question in your science notebook. So this goes over on the left-hand side. And we talked about physical science is the study of energy and matter. You probably want that there. It sounds like it's a definition. So when you drop a glass on a cement floor, it breaks. When you build a campfire, the smoke rises. When you place water in a freezer, it becomes solid. These are examples of events you may have observed in your daily life that can be explained by physical science. But much of what physical science deals with is not easy to observe directly. How much matter is there in the universe? How small is an atom? So these are things we can't see. So on the left side of your notebook, draw some diagrams or make some notes about the things we just read, your own thoughts about energy and matter. Revisit these pages as you work through the unit and add notes that answer those questions to the right side. So you could add any drawings, notes, on anything about how your ideas changed to the left side. So that's where you will enter that. So what is science? What comes to mind when you think of science? White lab coats and microscopes, textbooks. Write down some ideas about what science means to you in your science notebook. So again, on the left side, just jotting down a couple of things there. And then you'll see lesson goals. These things you do not have to write down, but it's just letting you know what we're going to be going through in the lesson. So at the end of the lesson, you should be able to do all the things listed here. So here we're going to describe science. We're going to describe how science knowledge changes over time. Describe that science is a way of knowing. Science is a way of knowing used by many people, not just scientists. It describes the qualities of scientists and engineers. It describes how advances in technology influence the progress of science, and science has influenced advances in technology. So here's an example. I'm going to pull this up and let you see. So we've got an example of basically everything we've covered so far, what it might look like in your notebook. So what is science? We know it's a body of knowledge and practices used by many people. They included some pictures. Practices equal asking questions, making models, investigating, interpreting data, using math. So more pictures included there. And then science leads to new technology, which helps advance science knowledge. They have a couple more pictures. So this is pretty detailed. We haven't pulled quite this much out of just reading that, but it just gives you an idea of what you could put in there. And then over here, they went ahead and put the lesson goals on the right-hand side, but we're going to put the guiding questions over here. And they're very similar. You'll see that in just a minute. And remember, you have to enable editing in order for you to be able to type or insert anything onto this page. All right, so we're going on. Here are the guiding questions. Notice they're very, very similar. So this is what you write down on the right. You just enter them right into that table and it'll get bigger. It'll edit. If you delete them by accident, so if you're typing a question here and you delete something or make a mess, up at the top, right above insert, you can't see it on my screen, but it's the little arrow back, and it'll kind of take away what you did and let you start over. So it's right above insert next to save. So that's just something to know that might be helpful for you. All right, so once you have those questions in, you can go through and try to answer them, and then you're ready to move on. All right, so we've got Introduction to Science. In the process of using scientific practices in this course, you will have the opportunity to conduct several experiments. It's important to review safe lab practices and techniques. Take a moment to review the laboratory and safety guidelines. So they have the guidelines in a downloaded document here that you could take out. You could insert into your notebook if you wanted to as a file. But it talks through all the things that you have learned so far. You've seen this every year when you start science, but it talks about lab setup, making sure your lab has adequate ventilation. When possible, open windows, turn on the fan, set up an electric fan, keep drawers and cabinets closed. So a lot of these things, we're not using a lot of, actually hardly any chemicals in science this year, especially they don't send a science kit. So these are all things that you would have at your own house. So they're really not hazardous chemicals unless it's a cleaner or like ammonia, something like that. You also want to make sure that if you're using anything glass that you are careful, usually closed-toed shoes, clothing that can be easily removed in case of an accident. You don't want to drop anything, high heels, anything like that. But again, you're at home, so this is a little different. Tie your hair back, remove jewelry. When you're wearing personal protective equipment, be sure not to touch your face, eyes, mouth, and body. And then it shows lab protocol. You obviously shouldn't eat or drink while you're doing a lab. You don't want to touch, ingest, taste, or smell any chemicals. Flames are not allowed in the lab area when you're using flammable gas or liquids. You want to keep chemical and solution containers closed until they're needed. And then when you're transferring chemicals from one container to another, you want to hold those containers away from your body. So all lab practices, again, that you have seen before. So they're just going through these. Again, not a lot of these apply to us. You don't have beakers and test tubes and things like that at home normally. But you want to be careful with glass. It talks about heating glass and making sure, you pick it up, make sure it's cooled down because you can't see that glass is hot. Don't put hot glassware in cold water. It can shatter. And then always wash your hands thoroughly after, making sure you would wash any chemicals you may have gotten on you away. So now that you've reviewed lab safety, you can answer the questions about the guidelines. So this just goes through and lets you go through and answer all these questions based on lab safety. Very easy stuff. What should be done with long hair? We don't always have to cut it back, right? But we could tie it back. What items should not be worn? High heels, sandals, dangling jewelry. If you splash acid on your skin, what should you wash it with? Remember, you have to be careful with acids and water. You've got to basically dilute the acid. If you add acid to water, that can be damaging. So a weak base is like a soap. And then what should you do at the end of the lab? Wash your hands thoroughly. Properly dispose of your waste. You don't pour any unused chemicals back into the container. You always dispose of those, and you clean your work area. And then now you could go through the true or false. Just for time, we're already almost 20 minutes in. I'm going to speed along here. So it takes us to the lesson review. Check your knowledge. So again, these are answers that are going to help you on those guiding questions. It gives you the answer here. So what is science? You've got the answer. How do science and technology influence each other? So I think 4 out of 5 of those are right here, done for you. Just have to copy them or type them in. So that takes us to the end. You want to make sure everything has a check mark, and you are finished. So as we wrap up with that, you will look for flip follow-up sessions to start in the next week or so. And then you can attend any Help Lab session that you see for extra support if you have questions. So have fun and have a great day.